In this problem, we are asked to determine the mobility of the two mechanisms shown here. At the left, we have the 5-bar linkage. And, at the right we have the geared 5-bar mechanism. Let's deal with these mechanisms one by one, and then we will do a comparison. First, let's focus on the mechanism at the left, the ordinary 5-bar linkage. This mechanism is built up from 5 links, 5 bars. Thus, L the number of links is equal to 5. There are also 5 rotating or pin kinematic pairs connecting the 5 bars together. Hence, the number of lower kinematic pairs, J1, is equal to 5. There is no higher kinematic pair. Thus, J2, the number of higher kinematic pairs, is equal to 0. Mobility, M, is given by 3 times L minus 1, minus 2 times J1, minus J2. Substituting the values of L, J1, J2, in the expression of mobility, gives that mobility M is equal to 2. Let's move now to the second mechanism, the geared 5-bar linkage. As the previous mechanism, this mechanism is also built up from 5 links, the ground, 2 gears, and 2 bars. There are also 5 rotating or pin kinematic pairs. There are 2 rotating joints connecting the gears with ground. There are 2 rotating joints connecting the gears with the bars. And there is 1 rotating joint connecting the 2 bars. Hence, the number of lower kinematic pairs, J1, is equal to 5. In this mechanism, we have also a gear kinematic pair, connecting the 2 gears together. Thus, J2, the number of higher kinematic pairs, is equal to 1. This is the main difference between the two mechanisms. The ordinary 5-bar mechanism does not involve any higher kinematic pair. On the opposite, the geared 5-bar mechanism involves 1 higher kinematic pair. Mobility, M, is given by 3 times L minus 1, minus 2 times J1, minus J2. Substituting the values of L, J1, J2, in the expression of mobility, gives that mobility M is equal to 1. We have succeeded to calculate the mobility of the two mechanisms. The ordinary 5-bar linkage has a mobility M equal to 2, or 2 degrees of freedom. The geared 5-bar mechanism has a mobility M equal to 1, or 1 degree of freedom. In the mechanism at the left, 2 independent parameters are required to describe uniquely the position of the mechanism. For example, we can choose the angles of the 2 crank bars as parameters. The positions of the 2 other bars depend on these 2 parameters. The 2 crank bars, the green and the blue bars, are the inputs or the driver links. Their motion is controlled by an external source of energy. In the mechanism at the right, only 1 independent parameter is required to describe uniquely the position of the mechanism. For example, we can choose the angle of the green gear as this parameter. The positions of the blue gear, and the 2 bars, depend on the angle of green gear. The green gear is the input or the driver. Its motion is controlled by an external source of energy. As the mobility of the mechanism of the geared 5-bar mechanism is equal to 1, only one type of motion can be delivered by the mechanism. Thus, for example, the blue gear can only rotate at the same speed as the green gear. Also, it can only rotate in the opposite direction to the green gear. In this mechanism also, the connection between the 2 bars can only go up and down, following a straight line. Also, if the driver gear is stopped, all links stop, and the mechanism becomes static. In the same way, the 2 drivers had to be stopped, to stop completely the ordinary 5-bar mechanism. However, for the ordinary 5-bar mechanism, stopping only one driver, blocking only 1 degree of freedom, does not make the mechanism static, does not stop the entire mechanism. Compared to the geared 5-bar mechanism, the ordinary 5-bar mechanism offers more flexibility. Different types of motion can be achieved by the 5-bar linkage, as the two drivers can be controlled independently.